Hey students, welcome to Chapter 11, Lesson 3. So far in Chapter 11, we've covered measures of center, and we've talked about three measures of center: the mean, the median, and the mode. And I find that most sixth graders have worked with those measures before. Lesson 3 is called Measures of Variation. So now we're going to look at a different way to look at your data and describe measures of variation of your data, not measures of center. We're switching now to measures of variation. And I find that most sixth graders, a lot of what we're covering in Lesson 3 is new. So we have quite a few new vocabulary that we'll put up here, and then we'll do an example. If you don't quite understand the vocabulary as we're writing it down, I think the actual example will help you out a lot. So the first thing I want you to write are measures of variation. So the measures of center that we've already covered, that describes kind of center points of your data. Measures of variation are used to describe the spread of your data. Is it spread out a lot? How the spread of your data, not the middle that measures of center cover, but the spread of it. So that's what we're going to write here. Measures of variation are used to describe the spread of the data. So again, today is about measures of variation, which are used to describe the spread of the data. Okay, the first, actually I'll highlight that, measures of variation, so that's what we're talking about today. And one measure of variation is called quartiles. And the quartiles are values that divide the data into four equal parts. If you think QUAR like quarter, quarter is 4 quarters in a dollar. Well, the quartiles divide your data into four equal parts. So the quartiles are values that divide data into four equal parts. Okay, so the middle of your data is the median, so that is actually one that's used when finding quartiles. And the other thing that we're going to look at are the first and third quartiles. So first quartile Q1 and the third quartile Q3. So working with the median, Q1, the first quartile, the median in the middle, and then Q3, those are the numbers that divide your data into four equal parts. And this will make more sense as we do the example. But the first and third quartiles, what those are medians of the data values. Medians of the data values less than the median. And data values, the median of data values greater than. And again, that sounds very confusing, I know, but it's really finding the middle of your data, the median, and then finding the middle of the first half, that's Q1, and the middle of the second half, that's third quartile. So first and third quartile, those, again, most kids, most sixth graders have not worked with those. So it's the medians of the values less than the median and the median of the data values greater than the median. So the middle of the lower half and the middle of the upper half. So again, the example that we cover, I think it'll make more sense when we actually do the example. The interquartile range. Interquartile range, we also abbreviate that IQR. That is simply the distance between the first quartile and the third quartile. So you subtract the third quartile minus the first quartile to get that. So it is the distance. The distance between first quartile and third quartile. Okay, that is the interquartile range. Also known as the IQR. Okay, the range of your data. Okay, the range of your data is the difference between the greatest and least data values. Difference between greatest and least values. That is the range. And finally, the last thing that we are going to talk about today are outliers. Okay, outliers in your data are values much greater or much less than other values. Okay, so values much greater or much less than others. Okay, so what does that mean, to be much greater or much less? The way you find that, the way you calculate is it an outlier or not, is that it has to be more than 1.5 times the interquartile range. Okay, so that is how you determine is something an outlier or not. So there's been a ton of writing in these notes so far. Outliers, and here's the key, more than 1.5 times the IQR. If you have a data value that meets that, it is an outlier. Okay, so now let's go through an example. I think that covering these in an example is going to make a lot more sense than just words and talking about them like this. Before we do that, though, the hidden treasure for this lesson is describe what it means if a number is prime. P-R-I-M-E. What is a prime number? What makes a number prime? And also give an example of a prime number. You might already know that, but again, if not, you can look it up. Prime number is today's hidden treasure. Okay, let's go through an example finding the measures of variation in a set of data. And our data today, the data we're going to look at are the numbers of penalties by some NFL teams. Okay, so pro football teams, NFL penalties. So for a whole season, we're going to look at some teams' numbers of penalties. And the data, we're going to look at 7 teams. One team had 104 penalties. Another team had 113. Another team had 68 penalties. Another team had 190 penalties. Another team had 77, 59, and 86 penalties. Okay, so there's our data, and we are going to find, oh boy, here comes Frank. I left the door open. Find the measures of variation for NFL penalties. Okay, let me grab Frank so he can say hi, and then I'll get him out of here. Come here, Frank. Come on. Oh, I see you, sweetie. I accidentally left the door open, and you know who is always going to come in when that happens. Say hi, Frank. Can you say hi? No. All right, you got to go. Sorry, buddy. Okay, so here's our data. We'll listen to Frank through the door. So we have to find the median, the very middle of our data, because that's one of the numbers that divides it into quartiles. So remember, to find the median, the big idea is got to get everything in order. So I scan my data, I look for the smallest number, and it's 59. Okay, I look at my data, the next smallest number, being very careful, 68. The next, 77, so I'm putting them in order, least to greatest, 86, 104, 113, and 190. 1, 2, 3, 4, 5, 6, 7 data values. 1, 2, 3, 4, 5, 6, 7. Okay, I feel confident that those are in the right order. So now let's go through finding measures of variability, measures of variation on this set of data. So first, let's find the median. So I'm going to cross out till I get to the middle. Okay, the median is 86. Now, to find the first and third quartile, what I do is I don't count the median, but I find the middle of all of these numbers, the lower half. So I'm not counting the median because it says the first and third quartiles are the medians of the data values less than the median. So I'm going to put my hand on the median, and then I count these. I find the middle of these values. I'm going to do the same thing with the upper half. I'm going to find the middle of those values. So I'm going to put my hand right on the median, and then I'm going to find the very middle. So I'm going to go like this. The first quartile would be 68 because that's right in the middle of the lower half. So I'm going to put a Q1 right above the 68. And I'm putting my hand on the median, and then I find the middle of the upper half. So I cross those two out, and my middle of the upper half is 113. I'm going to put Q3 right above that. Okay, so now I've found first quartile, is 68, and the third quartile is 113. Okay, so let's highlight those. So those are the first and third quartile. Again, it's the middle of the lower half of your data and the middle of the upper half of your data. That is how you find the first and third quartile. So from that, we can find the interquartile range. All I do is I subtract third quartile, subtract the first quartile, so I would do 113, subtract 68. The interquartile range turns out to be 45. Okay, so the span of data between here and here is 45. I can also find the overall range. So going back to our definition of range, it's the difference between the greatest and the least values. My greatest value is 190, the least is 59. That is my overall range. 190 subtract 59. So the overall range of my data turns out to be 131. The spread of my data overall is 131. So let's go back and highlight interquartile range. That was up here. Distance between Q1 and Q3. So I just subtract Q3 minus Q1. And what color did we have? Range. That looked like it was orange. The range of your data is the greatest value, subtract the lowest value. So again, it's really important you get your data in order when you're figuring out measures of variation. Okay, last thing we're going to look at are there any outliers in this data? Outliers, question mark. Are any values way far apart from the other data values? Do we have a really high value apart from others or really low value apart from others? So just a reminder, for it to be an outlier, it has to be more than 1.5 times the IQR away from either Q1 or Q3. So I know that sounds like a lot. Here's what it looks like. So I'm going to take my interquartile range and I'm going to multiply it by 1.5. So I already know my interquartile range, so I'm going to calculate that. IQR times 1.5. Now my interquartile range is 45. So I'm going to put in 45 for the IQR times 1.5. Put that in your calculator. 45 times 1.5 is going to give you 67.5. So now we have to look at Q1. Is there a data value that is 67.5 away, going this direction, lower from 68? Is there a data value that's more than 67.5 away from quartile 3 going this way? So what I'm going to do is take quartile 1. I'm going to subtract 67.5 from quartile 1, which turns out to be 68. So I would do 68 minus 67.5, and that gives me a value of 0.5. I don't have a number that's 0.5 or less, so I don't have an outlier this direction. Next, let's look at, is there a value that's 67.5 away, going that way from third quartile. So I would take quartile 3 and I'm going to add 67.5. And again, that came from 1.5 times the interquartile range. So I would take 113 and I'm going to add 67.5. Type that in your calculator and you get 180.5. Tip this down so you can see it. Is there a value that's further out than 180.5? And it turns out, yes, we do. We have this outlier out here. It's at 190, which is further away than 1.5 times the interquartile range. So my answer would be yes. 190 is an outlier. So we do have an outlier on the high end. So I'm going to highlight this outliers, and yes, we do on this example. So that covers measures of variation. So I know that these are new for a lot of kids. I would suggest rewinding and going back and looking how we went down through these. Really not that hard if you just follow the steps. You know how to find the median. Get your data in order. That's the biggie. That's a big one. Carefully get your data in order. Find the middle, very middle number, which is the median. And then you find the very middle of this set of data. That's third quartile. The very middle of your lower half. That's first quartile. You can use those to get the interquartile range. You know how to find the overall range of your data, and then you use that interquartile range to figure out, do you have an outlier in your data or not? All right, that does it for lesson 3. I will see you again soon.